Volumes. So volumes first started with area, and I think everyone got the area question correct on the test. How do we find area between two curves?
Top minus bottom.
Integral of the top minus the bottom. Okay? I think everyone was comfortable with the area. But then when we got to the volume was a little bit more difficult. So volume-wise, first we have volumes of revolution. When we have revolution, they're going to pick a line to revolve an area around. They could revolve horizontally, they could revolve vertically. It doesn't matter which direction we revolve around. And we had two options. Sometimes one method was easier than the other. Does anyone remember the name of the two methods?
Shells.
Shell was one, disk was the other. So disk was based off of circles. Think, disk, circle. What's the area of a circle?
Pi r squared.
Pi r squared. That's exactly the formula for the disk method. Now sometimes there's empty space. What happens if you have two circles and you want the...
You find the area of the smaller one, and then the bigger one, and you subtract.
You subtract. So disk, which really washers the full, you subtract the two areas. So we have pi, and we've used big R of x squared minus little r of x squared. Or I think sometimes we wrote it f of x squared minus g of x squared. It depends on notation. The only thing with f of x and g of x, you have to know f of x is the bigger function. From a to b, your bounds depend on your shape. Now disk is best. Sorry, I'm trying to remember. When your cross sections are perpendicular to your axis of revolution. Rev instead of revolution. I'm saving the other half for shell method. Shell was not based on circles. It was based on another shape. I want to remember what our other shape was. Close. Cylinder. Okay. It was based off of cylinder. So this one ended up with 2 pi. Again, just integral from a to b. H of x times p of x. And what did h and p stand for? H was your height. P was? It was your distance from your axis of revolution. So, yeah, we could call it radius. So height. I'd still maybe put distance from axis. Revolution. So again, 2 formulas you need to have memorized. You can't do these problems if you don't know what formula you're going to use. The disk washer method's a little easier to remember because it's just the area of a circle, pi r squared. We had one last formula for volumes, but it wasn't a volume of revolution. What other type of volumes did we have? The ones that just kind of pop out of the page, the cross sections. These ones are super hard and they're not super hard at the same time. So if it's just cross sections, the volume is just the integral of the area. Oh, I should have mentioned, if disk was best when you are perpendicular to the axis of revolution, when will shell be the best?
Parallel.
When you're parallel to the axis of revolution. So cross sections is just integral of the area. That can be any area. It depends on what area they tell you. Are you using a square? Then it would just be side squared.
That's my favorite one.
That is a nice one. Are you using a, please don't look at problem 4 yet. Are you using an isosceles right triangle? Then you have to do a little more geometry. So let's look at problem number 1, I believe was our
We're not supposed to look at
volume
4?
problem. Do not look at 4.
Not looking for. I'm looking at construction.
So on our mock exam, problem 1 was about volumes and areas. And it was one of our higher class averages. Because especially number 1, A, you guys all got the area. I'm pretty sure everyone got the area. So we don't really need to talk about A. It's just the integral from 0. Where would we have our final bound? On 1A, we start at 0. Where would we stop our area? Where they cross each other. And how do we find that?
Set them equal to each other.
Set them equal to each other. Solve for x. And you got 1 point just for having that correct bound. So make sure to write that stuff down. If you find where they intersect, write down that. Even if you get the rest wrong, that can still get you a point. So area, we were fine on. Part B is still area, so I still want to address that because it was a little more difficult. Most of you still did pretty good on it, but I want to wait and do our volume since we've started talking about our volume. So let's do part C. Find the volume of the solid generated when R is revolved about the line y equals -3. So we have our let me just draw a close approximation. There's our axis of revolution. This was our region we're talking about. Now I think everyone forgot this step. Before we can even start plugging this into the formula, our axis needs to be shifted, which means our functions are going to be shifted. Where do we shift our axis of revolution to?
The line -3?
That is the axis of revolution. Where should we shift that to? Where do we want it to be? X, or y equals 0.
Yeah.
Yes, y equals 0. We want it to be the x-axis or to be the y-axis. So we need to shift first. How do I shift a function up?
Yeah.
Add. So if we want this, we want to add 3. But if I move this up 3, what am I going to have to do with my other functions? Move it up 3. So all of my functions, let's see, 1 minus x cubed is the top one. To move it up 3, we're going to add 3. Sine of x squared is my bottom one. We're going to add 3. Because it's going to shift the entire thing up so that our axis of revolution is the x-axis. And our region is up here. We must do that shift. Now we can do our formula. So we have to decide, shell or disk. My brain is not remembering words today. Like, what's the other one? What's the other one? So we always, if we can, doesn't always work out, but if we can, we want to take our cross-section so that we can work with our x values. So we want our cross-section to be going like this. We don't want it to be going horizontally. So is my cross-section going to be parallel or perpendicular to my axis of revolution? Perpendicular. So which method worked better when we were perpendicular? Disk method. So we're going to do disk method. Disk was pi, and go from A to B, big R squared, plus little r squared. I didn't need an extra parenthesis there, so just ignore the extra parentheses. So where do we start? Where did it say to start our integration? What's my lower bound? 0. And why is it 0? That is not why it's 0.
Bounded by the first quadrant.
It's bounded by the first quadrant. They told us first quadrant only. So we have to start 0, because I can't use anything in the fourth quadrant. So we have the integral from 0. B was some decimal. Does anyone still have their...
7, 6.
Give me 5 decimal places because we've got to plug it back in.
176,497.
Thank you. Now, again, you don't have to keep writing that decimal out. If in part A you had said B equals 0.76497, and on every other integral you wrote from 0 to B, saves a little time. You can write it out. You don't have to do it this way, but it can save some time, and it can save some error in writing the decimal incorrectly on accident. So, we do our top function. What's our top function now?
1 6 plus
What should I do next? Squared. And then out of room. And then what do we do with the entire integral? Plug it in. There's no way you can do that by hand. So it's essential you do not forget to shift. You can shift in the y direction as well. Y direction if we need to move to the right. Your right. Backwards. Would we add or subtract? Subtract. It's opposite of what we expect. If we're moving to the left, we subtract. If we plug this entire thing in, what do you get? Did you bring the calculator back?
So you're telling me that I almost got this problem right, I just forgot to shift it by 3.
Yep.
Ah, could have saved my test.
So that one's an easy fix. It was something we hadn't had time to talk about yet because the
Which one do you
volumes,
want me to plug in?
the last
I
integral.
got
I think.
11.8407.
And this time you don't have to use 5, you can only use 3. If you want to keep writing 5 every time so that you don't forget, then feel free. They won't dock you for extra. And you could write it either way. You could put 11.840, get the point, or 11.841. and get the point. So then let's talk about part B. Part B was just the area. Didn't involve the volume. It was just the area, but they did make it a little more complicated. They said, okay, let's use a little logic here. The horizontal line y equals k is drawn through a point where the graphs intersect. Find k and determine whether this line divides k into two regions of equal area. Most of you guys had the general idea or got it pretty much correct. A few of you didn't get the correct k value. If it's the horizontal line, what would the equation for this horizontal line be?
Y equals a 9x value.
Y equals, and not the x value, it is not y equals 0.75 or whatever it was. It's the y value. If you have a horizontal line, you need to find that y value. So how do I find the y value? You already know the x value. How do we find y values? Plug it in.
Yeah, that's.
Okay. Well, yeah, put it into your calculator. You're going to plug in 0.7 into either of the functions, and you get the y value of 0.552. And then we're finding the area of the top piece versus the area of the bottom piece. How am I going to find the area of the top piece?
Oh, they do so. You take the integral of what you did before with the top minus the integral of horizontal.
Okay, so integral of 1 minus x cubed minus 0.552352. And then the second one would start at 0.5532. Whatever, 0.55232, whatever. Minus the bottom piece, minus sine. You'd find both of those, and then it did ask you to make a conclusion. So when it says make a conclusion or show the work that leads to your conclusion, you still need to state whether these integrals have equal area or not. So when you take the integrals, what ends up happening? Two regions are close but are not equal. And you need to make that statement. If it asks you to determine if the regions have equal area or not, you better make a statement saying whether they're equal area or not. Yes?
How did you get the 0.552352? You just plug it.
We plugged the 0.76497 into either 1 minus x cubed or into sine of x squared. We're finding a y value. And since it's where they cross, that y value should be the same, just like the x value there is the same. If we were to do a shell method problem, let's take this same area same region, and let's rotate it around x equals 2. So we can practice our shell method. Now for disk method, you want to shift the whole thing. For shell method, we do not want to shift the whole thing. Disk method, you need to shift the whole thing. We'd shift this all so that it was at the y-axis. shell method, we don't want to do that. Shell method, we add 2 pi, a to b, h of x, p of x. Now again, our goal is to make this as easy on us as possible. The reason I would want to use shell method on this one is because I still want to go up to down if I can. Because then I can use my x values. I don't have to get everything in terms of y. But when I take that cross section, it's parallel to my axis of revolution. So we want to use shell method instead of disk because my axis of revolution is parallel to the cross section I want. So the height is easy. How do I find the height? That is still the bounds. Our bounds will not actually change on this. How do I find the height? I want the distance between this top function and this bottom function.
Minus the integral minus the top
Minus the functions. So h of x is just 1 minus x cubed minus sine of x squared. Did I remember those functions correctly? Yes? Okay. Our bounds actually won't change. We still start at the beginning of our shape and end at the end of our shape. We're not going integrating to our axis of revolution. We're only integrating where the shape exists. And then p of x can be the hard part on shell method. Shell method is actually pretty easy because h of x, you just do top minus bottom. P of x, we want to go from our cross section to our axis of revolution. Well, first we need to know, what do we consider this distance to our cross section? X. But I only want, let me change the color of one of these. I only want the green distance.
2 minus x.
We know the entire distance is 2. We want to get rid of the x so that we're just left with green. So we'd have times 2 minus x dx. And then again, we'd just plug it into the calculator.
Okay.
And then cross sections. Let's use this same area and do a cross sections problem. This is going to be our last problem, and then we're going to be working on fixing problems from our AP exam. Okay, so cross sections, let's use the same functions since we already have been working with them. And let's find the volume if, let's see if I can find the correct way to state this. If cross sections perpendicular to the x-axis what shapes could we use?
Hexagons.
What shapes could we actually use? We have squares a lot of the time. Let's do a half circle. Referring to the x-axis that are half circles. Diameter in the xy plane. Okay, they're going to give you a bunch of garbage that doesn't matter.
Well, that's uncommon.
It's because mathematicians are picky and they want all the correct, exact words.
Well,
But
we're
really,
Also as lazy as crap.
And yet they go through all the effort to put this
Okay.
up there.
what should we really focus on in all this garbage?
Half circles.
Half
volume.
circles.
X-axis,
Okay.
diameter.
We know we're doing volume, we know they have cross sections, we want half circles.
So
We
does it
know the
matter
area of a
if
half
it's-
circle. What's the area of a half circle? I'm not even gonna worry about my functions yet, I'm just saying, what's the area of a half circle?
Pi squared over 2.
So no, I know I am integrating pi r squared over 2. Again, we'd still have the same bounds that we've been working with because we've been working with these same functions. Now I just need to figure out what is r. Out of all of that, I want to focus on, hey, what am I actually finding area for? If it was a circle, we'd say, okay, we're going to integrate side squared. If it was an equilateral triangle, we'd have to do a little geometry. It was like square root of 3 over 2 times side squared. Not sure I have that one memorized, but you could figure it out by, you'd have to do Pythagorean theorem to figure out height. You could figure out if it was an equilateral triangle. So radius, they said the diameter is in the xy plane. So what would the diameter be using our two functions?
The top minus the bottom.
Top minus the bottom. All of our volumes in our areas usually go back to top minus bottom at some point. You have a question or you just? Okay, so the diameter would be the top minus the bottom. But what do we need for this question? Melinda, what do I need? I know diameter, but what do I need? Radius.
I was like, did we already?
Find the diameter, cut it in half, and
And that's our radius. That's exactly what we should do. Okay? So to find the radius, we just do top minus bottom
We'll keep trying to cut it in half to see what it is.
over 2.
Terrible.
So then we just plug in our functions. We have pi 0 to
Depends.
0.765
Thank you.
pi.
Actually got most of
We
these.
were already over 2, and then we're going to have over 2 within this because we had to divide to get our diameter.
Divide the diameter.
And then again, we just check that into our calculator. This one, we would not need to solve by hand.
Unless you are in a multiple choice set that you have to.
If it was only a polynomial, they might make you solve it by hand. If it was only a polynomial, how would we solve this? If I had 1 minus x cubed minus x squared, how could I integrate that by hand? You have to do something before you can do that.
you need to factor in the square
You need to FOIL.
or that.
Right idea, wrong name.
So if you boiled in the pie, would it just go to the top? Or would it go to the top and the bottom?
Good, so just pi over 1.
Okay.
Yeah.
The answer is 0.172. See how I used that.
Thank you. Okay, so first I want you guys to finish question 4. We're gonna
That's the one we're
train-
not supposed to look at.
Yes, that is the one you're not supposed to look at yet. I want you to finish it first before you compare it to your packet. Then, I want you to compare what we did on question 3 and question 4 together with what you did individually on your packet. See where you made your mistakes. And then if you have time after that, I want you to talk about your multiple choice questions that you missed together. Not everyone missed the same question, but that means you could ask someone, hey, I missed this one. How did you do it?
You
I
know,
want you to talk about it together first before we talk about it all together as a class.
in my experience, I was basically